Okay, now we're going to talk about what you need to do whenever you have to apply multiple derivative rules. On your notes packet, you'll see some clues as to what the expression will look like or might look like whenever you need to apply the power rule, something to a power, the product rule, something multiplied by something else, or the quotient rule, an expression divided by an expression rule. Now, the chain rule, there's not really a basic form, but I can give you some things that you'll see. Whenever you need to apply the chain rule, if you see clues on when you would need to apply the chain rule, if you see, just like the ones in the previous video, a trig derivative of something other than x. So the trig derivative of something or an expression, to stay consistent, expression, you need to apply the chain rule. If you have a root of an expression, more than just one x term, you'll need to apply the chain rule. If you have, what else? Oh, an expression raised to a power, which looks like the power rule, but when I say expression raised to the power, I mean like an entire expression, like 3x squared plus 7, like multiple terms. Power rule is when you would just have one expression or one term raised to a power. So those are some three things to look out for whenever you're trying to find the chain rule. Okay, so let's get to work. It'll be helpful to color code and highlight as we go through here. So if we look at example 10, again, this is on page 42 in your notes packets, and then we'll do some examples from Delta Math. So for the following, decide the form of f of x and then find the derivative. So I'm going to look, and right off the bat, I see one product right here, one factor, being multiplied by the parentheses. So far, I know that I'm going to have a power rule. Not power rule, product rule. Okay? And then, in addition to that, on the second factor, I also see that there's parentheses raised to an exponent, so that tells me there's an inside function. And I'll also have a chain rule to apply within the product rule. And so what I'm doing right here, automatically there's a picture that pops up. Okay, so here's what I'm doing. If you ever go skiing, snow skiing in your life, whenever you get to a new slope that you've never been on before, or even the new slope for the first time of the day, and what you need to do is you need to get to the top of the slope and then kind of look down and map out your path that you're going to go down the mountain. Because if you don't, there's a good chance that you'll run into something you don't expect. And then when you're going kind of quickly and you hit something you don't expect, you could fall and get injured or have to make a decision really quickly, and that could injure your knee. So you want to look at the path you want to take, kind of map it out in your head, and then go from there. And so, yeah, after you make a map, you might have to adjust as you go. But generally, look, if you make a good path, then you'll have an easier way down the mountain. Well, with multiple derivative rules, you need to do the same thing. Kind of look at what you have, map it out, and then once you map it out, then you can start finding the derivative on that path. Now, if you don't, this could be you whenever you try to take a derivative. So let's not do that. Let's make a plan. All right, so we made a plan here. We have a product rule, and then in the second factor of the product rule, we've got the chain rule. So let's go through and start finding the derivative. So I'm going to rewrite this, but first I'm going to color code it as I rewrite it. Let's see, so we've got f of x equals, the first is going to be x squared. the second is where I'm going to have my product rule and chain rule. So to the fourth, and then my inner function is 2x minus 3. Okay, so then I want to find f prime. So let's find the product rule. So first is x squared times the derivative of the second. So the derivative of the second is going to include the chain rule because I've got to take the derivative of this part. So 4 parentheses to the third power, bring down what's inside, times 2x minus 3, times the derivative of the inside, 2. So that's first derivative of second plus the second, which is 2x minus 3 to the fourth power. I don't have to do a chain rule here because I'm just copying down the second part, times the derivative of the first. The derivative of x squared is 2x. And then this is the derivative. So if you want to, Delta Math will take this answer, but if you want to simplify it, you just look and see. Now, whenever you have the plus sign, you got to be careful before and after the plus sign. But before the plus sign, I've got two constants I can multiply together to get 8x squared times 2x minus 3 plus, and then I've got the 2x, I'll move to the front, times 2x minus 3 to the fourth. And generally, we'll leave derivatives in factored form like this. And if you even notice, let's see, it's written somewhere up here. In general, we prefer derivatives in factored form if possible. So we'll just leave it like this. All right, the second one. Let's make a plan. I've got f of x equals x times the square root of 4 minus x squared. I see a square root of an expression, so automatically that tells me I've got a chain rule happening. So the outside function would be the radical. The inside function will be the 4 minus x squared. And then I also have x times that. So looks like we have another product rule. We've got a product rule and a chain rule again. And the chain rule is within the product rule. So let's rewrite it. F of x equals, the first factor is x times, now I'm going to go ahead and change the square root to something to the 1/2 power. And then the inside function is going to be my, I need another color here. Inside function is going to be the 4 minus x squared. All right, so here we go. F prime equals the first, which is x, times the derivative of the second. So derivative of second is going to involve the chain rule. So 1/2 parentheses, subtract 1 from the exponent to the negative 1/2, and then carry down the 4 minus x squared, times the derivative of the inside function. Derivative of 4 is 0. Derivative of negative x squared is negative 2x. I'm putting this in parentheses so I don't think I'm subtracting 2x. So I did first derivative of the second part plus the second part, 4 minus x squared to the 1/2, times the derivative of the first, and the derivative of x is just 1. And so there we have it. If we do want to simplify it a little bit, let's see, f prime of x. I'm looking before the plus sign. I have a 1/2 times a negative 2 is negative 1, and x times x is x squared. So it looks like I've got negative x squared. And then to the negative 1/2, this part that's to the negative 1/2, that's the same as putting it in the denominator with the under a square root. So 4 minus x squared. Bring down my plus sign. 1 times anything is itself, and I have another square root. So plus the square root of 4 minus x squared. So then let's continue. Ooh, now we have a delta math example, and we have a 3x squared times cosine to the fourth of x. I'm going to rewrite that cosine to the fourth, so that might help me see things a little bit easier. Y equals 3x squared times cosine of x to the fourth power. And so let me examine what we have here. I do see a product. I see 3x squared times this cosine to the fourth. So far I do see a product rule. Boom. Is there a chain rule in here? Yes, because I have parentheses to the fourth. So I need another layer of highlighter to spot the inside function, which is just the cosine part. So I've got a product, but then inside the product rule, I also have a chain rule as well. So then let's rewrite everything. Let's use purple this time. Okay, so y equals 3x squared times cosine of x to the fourth, but my outside function is going to be the parentheses to the fourth, and the inside function is going to be the cosine of x. All right, so here we go. dy dx equals first, which is 3x squared, derivative of the second, so 4 parentheses to the third, carry down the cosine, and to keep finding the derivative of the second, I need to multiply by the derivative of cosine, which is negative sine of x. I need parentheses around this cosine. So I did first derivative of second plus the second, which is cosine of x to the fourth power, times the derivative of the first, which is 3x squared. The derivative of 3x squared is 6x. And here's my answer. So let's see if there's anything I can simplify before the plus sign. I have a 3, a 4, and a negative 1 that can all be multiplied together to give me negative 12x squared cosine of x to the third, or I can go back to writing it cosine cubed of x times the sine of x, parentheses around each x, plus that 6x. Normally we see that in the front, so plus 6x cosine to the fourth of x. And I'm going to enter this into delta math, and I'll come back and show you what delta math says. Okay, so delta math said I was right. Yay! That's good because I'm the teacher. But look at the bottom. So I entered the simplified version, but also notice they would have taken the other part as well. They would have taken just the 6x cosine to the fourth minus, they would have taken the unsimplified answer as well. So both answers are totally acceptable. So honestly, it's probably better it'll be easier on you to enter the unsimplified answer. But if you run into issues because sometimes we forget parentheses, go ahead and simplify it. That can lead to fewer issues as far as fewer entry error issues as you're entering these answers. All right, now let's try one that looks a little different. Oh, this one looks like a lot because we have a fraction. So let's just take a step back and make a plan. I do see a quotient. So I see a top function divided by a bottom function. So automatically I know there's going to be a quotient of some kind. Okay, so we're going to make a list, quotient. And I'm even going to come over here and be like top, bottom, because there's other things happening in the numerator and the denominator. Okay, so in the top, if you notice, I have sine of something else. So within the top, I have a chain rule. So I need to apply the chain rule in the top. And then also in the bottom, there's a square root of something. So I also have a chain rule in the denominator as well. So when I take the derivative of the top, I know I'm going to have to find, use the chain rule. When I take the derivative of the bottom, I know I'm going to have to apply the chain rule as well. So let's try to rewrite this with some color. Y equals sine, and then the inside function will be 4 minus 4x cubed over. I'm going to go ahead and change the square root to parentheses to the 1/2, because that will be the outside function. And then the inside function we'll say is 3x cubed minus 6. That pen is really thick. Okay, so let's do this. dy dx. I'm going to apply the quotient rule, which is low d high minus high d low all over the low squared. So I'm going to copy down the low. So parentheses 3x cubed minus 6 to the 1/2. Just copy it down. Derivative of the high, we do need to apply the chain rule. So derivative of sine is cosine of the parentheses. Just carry down whatever's in the parentheses. Low, d high, and I need, so that's the derivative of the outside function. Derivative of the inside function is negative 12x squared. So low, d high. So minus the high, I'm just going to copy down the numerator. Sine 4 minus 4x cubed. Derivative of the low, so I'm going to start with the chain rule. So 1/2 parentheses to the negative 1/2. Carry down what's inside the parentheses. So low d high. And then I need to take the derivative of the inside function. So derivative of 3x cubed minus 6 is 9x squared. So I did low, derivative of the high, minus the high, derivative of the low, all over the low. And so if I square a square root, I'm just going to end up with 3x cubed minus 6. Here is my derivative. Now, it might be a little annoying to enter all of this into Delta Math, so it might be worth your time to simplify, but Delta Math would take this answer. But if we did simplify it, I can look before I get to the minus sign, negative 12x squared. I can bring that to the front. It's not going to get much more simple, though, because there's a lot going on here. Negative 12x squared. I could write the square root because to the 1/2. 3x cubed minus 6 cosine of 4 minus 4x cubed minus, and then on this part I can multiply the 1/2 times 9x squared, 9/2 x squared, and then the sine part, sine of 4 minus 4x cubed. And then this part, I can't move it to the denominator because there's this minus sign that I would have to take care of before I would do that. So I'm just going to leave it as to the negative 1/2. Over the square root squared, which is 3x cubed minus 6. Or you can even leave it as the square root squared. You can leave it like that as well. It's not much more simple, but Delta Math will take both versions. Here's another example. Not quite so much going on this time because we don't have the chain rule in both the numerator and the denominator, but I can say I see a quotient rule because automatically I have a fraction. So there's a numerator and a denominator, and then in the denominator there is a square root, which indicates to me that I'm going to need to use the chain rule. So my plan is to use the quotient rule. The top, or the numerator, there's only just the power rule in the top, but in the bottom, in the denominator, I'm going to have to use the chain rule. So let's write this with some color. I've got 2x cubed over, and instead of square root, I'm going to write to the 1/2 power. Let's see, parentheses to the 1/2 power. And then, let's see, green, 4x squared plus 3. And actually, I want the fraction bar to be black and the parentheses to be purple, just to stay consistent with the way that I've been labeling. All right, so now let's find dy dx. I need to apply the quotient rule, which is low, so just copy down the denominator. Derivative of the high, so derivative of 2x cubed is 3, no, not 3, 3 times 2 is 6. 6x squared, low d high, minus the high, which is 2x cubed, derivative of the low, let me just extend my fraction bar, derivative of the low, so that's where I apply the chain rule. Bring this 1/2 down to the front, so times 1/2, parentheses, the negative 1/2, carry down what's inside, then multiply by the derivative of the function on the inside. So low, d high, minus high, d low, all over low squared. So all over the square root of 4x squared plus 3 squared. Done. Then as always, you'll have some trig examples. So here I have f of x equals 2 sine of all of that. So let's try to color code this. F of x equals, we've worked with this a lot, so I can go ahead and tell you the outside function. I have a chain rule, by the way, because I have sine of something else. So sine, parentheses. But then within that, there is something cubed. So it looks like I might have some multiple chain rules going on. So a chain rule within a chain rule. Yes, that's possible. So parentheses cubed. And then my very, very inside function is going to be 4x squared plus 5. All right, let's do this. F prime of x equals derivative of the outside purple function. Derivative of 2 sine is going to be 2 cosine. Then I'm just going to copy everything else down. Parentheses 4x squared plus 5, parentheses cubed. So derivative of the outside times derivative of the inside. Okay, that inside is my next inner function, so that's parentheses. So I'll bring the 3 down to the front. 3 parentheses squared, because I subtract 1 from the exponent. Now just bring down what's on the inside. 4x squared plus 5. Now take the derivative of the inside function. 4x squared plus 5. Derivative of 4x squared plus 5 is 8x. 8x. There it is. So chain rule in a chain. Chains on chain. This is our last example. Don't let those square roots scare you. Just remember square root is the same as to the 1/2 power. So let's write this. Again, we're going to have chain rule for it because there's a cosine. So y equals, my first outside function is 4 cosine, parentheses, chain, okay, with the purple chain. Then inside of that, I have something raised to the 1/2 power. So that's where I have a second chain rule. So a chain rule and then another chain rule. So my next inside function is the parentheses to the 1/2. And then all the way on the innermost part is that 5 minus 4x squared. So let's find the derivative. Dy dx equals, derivative of 4 cosine is negative 4 sine, parentheses, bring everything down. 5 minus 4x squared, 1/2. Okay, now derivative of the blue part. So I'm going to bring that 1/2 to the front, parentheses to the negative 1/2. and then bring down whatever's inside that parentheses, 5 minus 4x squared. Then derivative of the innermost function, derivative of 5 minus 4x squared is negative 8x. And we are done.